The substitution method. Objectives. By the end of this lesson, you should be able to evaluate a limit using the substitution method when applicable. So one of the reasons we develop continuity is so that we can apply the substitution method for evaluating limits. So this says that if we have a function that's continuous at x equals c, then the limit is just equal to the function value. So in other words, the limit as x approaches c of f of x equals f of c. So we can evaluate a limit by now just substituting x equals c into the function. So just plug in x equals c, provided we have continuity at c. And this is a lot easier than the previous methods we've been using, like the numerical approach of finding a table or graphing the function in order to analyze it. And this is going to give us an exact answer. So let's just do a few examples. So in this example, I want to evaluate the limit as x approaches -2 of x squared plus 4x minus 9. So the first thing we have to remember is that x squared plus 4x minus 9 is a polynomial. So it's one of the known continuous functions that's continuous everywhere in its domain, and its domain is all real numbers, so that includes -2. So now, applying the substitution method here, we have that this limit is the same as just taking the -2 and substituting it into the x values. So -2 squared plus 4 times -2 minus 9. So we'll get 4 minus 8 minus 9. So this is going to become -4 minus 9. So our limit is -13. So because this is a continuous function everywhere, -2 falls in that domain. So we can just go ahead and substitute -2 into the x values and get out our limit value. So the limit value equals the function value. In this next example, we want to evaluate the limit as x approaches pi over 2 of cosine of 2x. So this is going to take a little more reasoning to show that cosine of 2x is continuous. Well, cosine x and 2x are each continuous functions, and this is the composition of cosine x and 2x. So because it's a composition of continuous functions, it too is continuous. So now we can apply the substitution method. So we're going to take pi over 2 and substitute it into x. So this is cosine of 2 times pi over 2, which is the same as cosine of pi. So the 2's are going to cancel. So cosine pi, let's draw ourselves a little unit circle. Pi is over here at this coordinate point, -1, 0. Cosine is the x value. So cosine of pi is -1. So we just went ahead and substituted pi into cosine 2x because cosine 2x is continuous on its domain. And the domain of 2x is all real numbers, the domain of cosine x is all real numbers, and the composition of continuous functions is continuous. So now that we have the substitution method and the notion of continuity, we can finally get to some AP-style continuity questions. So these are questions that would be more challenging multiple choice questions or even a portion of a free response question. What I want to do is find the value of k so that f of x is continuous everywhere. And f of x is this piecewise function, 2 when x is less than or equal to 0, and x squared plus k when x is greater than 0. So what we're going to do is we're going to graph this piecewise function, or try to graph it, and see if we can get a little bit of intuition about what k should be. So the function 2 when x is less than 0. Or less than or equal to 0. So here's 0 on the x-axis, so the function 2 is a horizontal line at 2. So let's draw that horizontal line at 2. And it's 2 when x is less than or equal to 0. So I'm going to have a filled-in circle at 0. And then it's the function x squared plus k. So that k is the value that we're searching for. And hopefully you recognize x squared to be a quadratic function. So the value that we're missing, this plus k, this number, is going to end up being the y-intercept. So what we're trying to draw here for x values greater than 0, so off in this direction, we want to draw the other half of the parabola. And what we have to find is that k value, the y-intercept in this example. so that this whole entire piecewise function is continuous. I never have to lift up my pencil when I draw it. So as it currently stands at negative infinity, I can draw this function without lifting my pencil. So right here at 0, so I have this y value of 2, I want to make sure that this is where the parabola is about to extend from. So I want a parabola that's going to look something like this, off to the right side of 0. So this parabola here should hopefully strike you as x squared plus 2. So this thing has a y-intercept at 2, making our guess for our k value 2. So k in this example is going to equal 2. But if this were a free response question, we would actually want to show a little bit more work than that. This is a proof by graph, and that's not acceptable in AP Calculus. So if this was a multiple choice question and you reasoned the answer to be 2, then that's fine, but we actually have a formal way to do this. So if we want continuity everywhere, we need the limit from the left to equal the limit from the right. And the one place that we're concerned with is 0 at this point. So we want to make sure that the limit as x approaches 0 from the right of f of x equals the limit as x approaches 0 from the left of f of x. And if these two limits are equal, and if they both equal f of 0, well then we know we have continuity. So we're going to force this to happen so that we can find k. So the limit as x approaches 0 from the right. So 0 from the right, values bigger than 0, means I'm going to have to look at this function here, x squared plus k. So this would become the limit as x approaches 0 from the right of x squared plus k. And this would have to equal the limit as x approaches 0 from the left of the function 2, because values to the left are less than 0, so now the function is 2. And both of these are going to have to equal f of 0. So f of 0, 0 is defined for the top function. When you plug in 0, you get out 2, is 2. So now, this limit here, the limit as x approaches 0 from the right of x squared plus k, the substitution method tells us that we can go ahead and substitute 0 in for x. So the substitution method also allows us to evaluate limits from the right and limits from the left by using direct substitution, provided that the function's continuous. Well, x squared plus k is a polynomial, so it's continuous everywhere. So let's substitute 0 in for x. So 0 squared plus k is going to have to equal, well, the limit of a constant is a constant. So the limit as x approaches 0 from the left is 2. And that has to equal 2. So 0 squared is 0. What I have is that k has to equal 2, which has to equal 2. So what's the value of k? The value of k must be 2. So this would be the more formal way to solve for the value of k that's missing in this piecewise function so that this original function is continuous everywhere. So in this next example, we're again trying to find the value of k that will make this a continuous function everywhere. So we're going to go ahead and graph it, or we're going to attempt to graph it to build our intuition again on that value of k that we're searching for. So we're going to go ahead and start by graphing x squared plus 2 when x is greater than 1. So here's my 1. So we'll go ahead and graph x squared plus 2. So that's going to be a parabola with a y-intercept at 2. So it's going to be this parabola here, and I'm going to draw it as a dotted parabola at first. So when x is greater than 1, I want to shade to the right of this parabola. And when x is greater than 1, means that there's going to be an open circle here at 1. So specifically at 1, 3 is where I'm going to have that open circle. So let's erase those points that don't matter. And what I'm trying to do now is find this value of k here so that this line, because x minus k is the graph of a line, is going to complete the function and make it continuous. So it's going to be some line over here, and I want to figure out basically its y-intercept so that I can have a continuous function. I can fill in this hole and continue the graph down here. So this one is already a little bit trickier than the last one, right? It's not just as simple as looking at it. So what I need is I need to figure out what value I am going to be able to plug in so that I end up going through this point. So let's use a different color. I want to make sure that I go through this point and I have a slope of positive 1. So let's go ahead and try to continue this line. If it has slope 1, it's going to go down 1, left 1. And then down 1, left 1 again, down 1, left 1 again. So here's my line of x minus k. So what does the k value need to be? And so this one's tricky because it looks like the k value should be 2. But that's not the case. So what is the equation of this line right here? This is the line x plus 2. So if k is behind a minus sign here, then that must mean that k has to be negative 2. So that I end up with x minus negative 2, which is x plus 2. So our k value is going to be negative 2 in this instance, which we could find by drawing the graph like we did, and this is supposed to look more like a parabola, sorry. Or we can use the more formal strategy that we would need to use on a free response type question, which is evaluate the limit from the left and the limit from the right of 1 this time. So the limit as x approaches 1 from the left means we're going to use the function x minus k. That has to equal the limit as x approaches 1 from the right, which means I have to use the function x squared plus 2, and that has to equal the function value at 1, so that has to equal f of 1. So our direct substitution, our substitution method, will allow us to substitute 1 into this polynomial. A line is a polynomial. So if I plug 1 into this x, I get 1 minus k has to equal, I can substitute 1 now in for x squared. So I'm going to get 1 squared plus 2, which has to equal f of 1. And f of 1 is obtained by plugging 1 into the top function. So I get 1 minus k again. So this is really two separate equations, but I'm only going to solve one. So let's just solve this left part over here. So when does 1 minus k equal 1 squared plus 2? Because that's the same as asking when does 1 squared plus 2 equal 1 minus k? So 1 minus k equals 3. So if I subtract the 1, I get negative k equals 2, and then divide by a negative 1, then I get k equals negative 2. Which, again, was the same answer we got with the graphical approach, but this is the formal approach that would be needed to find the value of k should this be a free response question.